what sort of got me thinking about this is I'm a big fan of the web performance group, and we talk a lot about how to make things faster, especially on the front end, how to make sure that things are working well. And one of the things that I spend a lot of time thinking about at AppNeta is not only how to make things that we own and control faster, but also things that we don't own. So, any application you build, you necessarily have access to a bunch of the code and some of the infrastructure, depending on where you're actually running. But there's also a bunch of people out there who rely on Office 365 and Google Apps, and it turns out that there are people who really need to make sure that those applications work. So there's tools out there for them too. And how can we use that in thinking about, or some of the principles there, and thinking about load testing the applications that we build. So, but first, let's talk about testing. Load testing has to be a subset of testing. It's in the name. So, if you sort of break it down, I sat down and scrolled out. What are the ways in which I would want to test an application before it goes out, and people actually use it, and I get embarrassed that it's not working anymore. So, the right side of the pie chart is sort of you start small. I've got some object, I test it. I've got some larger set of objects that interact with each other. I want to make sure they functionally work. And then I've got sort of my application integration, test that to make sure it's correct. I want to make sure that it's usable. I'm going to go put it in front of somebody and hope when they click around that they don't get lost. Also security testing, making sure that all the data is safe and it behaves the way we think it should, and performance is one of those. So I realized when I was looking at this list that there's actually something interesting about it, that it's not just... Performance is a little unique in here, and arguably security is close to it, but performance is one of the only ones in here where you really need a lot of pieces in order to make it work. You can take a piece of your code, and I'm gonna nail it down and mock out a bunch of stuff, and I'm gonna test that thing. Get really up close and personal and stare at it and understand what's going on. But if I want to understand what my code is doing when it's got 100,000 users and there's crazy stuff going on in the back end, people are trying to upload 3 gigabyte files, you got to go 77 miles an hour, and maybe something's going to break before you can say that it actually works at 65 miles an hour. So it's a different setup. It's actually a different beast because you can't really nail it down and say this is working the way I want it to. And a lot of this comes from just, you have your code, especially your back-end codes, but including the front end, it all sort of works together and you control that, but that's not your app. If I go to Wayfair.com, Wayfair.com is not actually just the code at Wayfair.com, there's a bunch of other stuff there. We're at AppNeta that we're totally sold on this whole cloud thing. We're increasingly taking pieces of especially data storage and just pushing everything out into services we don't control. Places that we don't understand the performance of aside from what we write on the website. That I know ELB is supposed to distribute a bunch of requests across my various app servers. I know that there's supposed to be web caches out there that are sort of doing their thing, and Chrome has some policies which I can really hook into, and their code's mostly right. I can go look at it if I really cared, but I don't have time to go read the 5 million lines of C++ code to make up Chrome or whatever the number is. And then on the back end, there's a bunch of other services which, when I'm sitting there hands on a keyboard, sure, I don't actually post information to Stripe or I store something in a local local memcache, but maybe that becomes Elasticache in Amazon. And this whole system becomes much more complicated in trying to test what's actually going on if I want to see it from a performance perspective. Because that memcache instance I have on my local instance has a totally different reaction to data than memcache in production if it's off as a service somewhere. Or if my database is tuned on my laptop with an SSD, who knows what Amazon is running RDS in. So in order to actually test all of this, I feel like I do need to actually build up a full replica of production. And that really means getting to the level where I've got production level load on the system. I'm looking for getting to that 65 miles an hour, 85 miles an hour, 100 miles an hour where is it going to break, where are the wheels going to fall off, and what's going on. So great, let's get there, but that's going to mean a bunch of production level servers as well. I need to literally replicate production, or maybe I just do it in production? Well, I need to replicate production, and that means the cost that comes with production. And if I have this system that's sitting next to production because I need it to look like production, and I've built it to kind of look like it, but I don't actually send users to it, I'm probably going to end up with stuff that's all over the place. I left it up for a day, and all of a sudden this part got slower because it turns out it's not exactly the same as production. So I also have production level bugs. And by production level bugs, I don't just mean the scalability issues and the stuff I'm looking for necessarily, but it means that when I deploy a really complex system, it kind of hurts to get out there and deploy that kind of system. Any change I make is just as complicated and just as error prone and just as likely to fall over as my real production system. I've certainly only got time in the day to manage one of those, not two. So that's challenging. And a totally reasonable reaction is to say, screw it, let's do it live. I'm going to just push code into production, and I'm going to do it with 1% of my users at first, and I'm going to have really aggressive monitoring set up, and I've got really robust rollback mechanisms, and if stuff really starts to go down the tubes, then I'm going to feather in and out of production and make sure that I understand the performance characteristics and have sort of operational clarity around that, because I'm going to say that production is an ops problem, not a dev problem. And when I do find problems in the code that look like they're causing problems for the ops team or whoever is in charge of production, maybe it's individual devs at your organization, then we'll push it back to them. They'll fix it. We'll redeploy it. We'll see what happens. It's not the worst opinion, actually. It does work, especially if you're optimizing for sort of minimum number of bug hours per person or something like that. You get some really fast feedback, and if you're willing to fix it quickly, that works. But that doesn't work for everyone. That does actually mean you're testing on users and you're testing on real human beings, and maybe that's not acceptable for you. If I run a search engine and it occasionally comes back a little bit slower or returns weird results, okay, not a big deal. If I return if I'm a bank and I occasionally tell you your bank account balance is missing, that's less okay. So the other standard answer is scripted. I know what I want my system to do. I'm going to maybe reuse my unit tests, my functional tests, my integration tests, and I'm going to run them at really high volume in production and understand understand the system itself. So I didn't have any tests, so I wrote some. How many people have written a load test that looks like this? Yeah, there's a couple of hands. I wrote a load test that looked like this at one point, and I was embarrassed when it found bugs. I couldn't believe the system fell over with something like this. It's just spawning a bunch of shells in the background. Jesus, hundreds of servers. Anyway, but this is basically what a lot of load testing software does. You just say, I want to do this, and it does it a bunch. You can get a little bit more sophisticated. There's tools like Apache Bench that'll let you say, give you a little more control and feel like you're using a real tool. I want 10 connections at a time, 100 connection. I want 100 rounds of this, and go hit these endpoints. And you can do that, and it'll actually go hammer the web service and get you information about it. But you're still scripting a particular action or a particular endpoint that you want to hit. Now, of course, endpoints aren't user experiences. There's a lot of work to be done between I created some endpoint that returns JSON and saying, I have an interface people can click around in it. So the next level of sophistication that a lot of people like to use is Selenium. You can hook in and actually write either script it yourself or just click around in the interface and record what it does. And you can take these scripts and then run them from in that same sort of way. Maybe it's just a for loop on a command line. Maybe it's something a little more sophisticated. And there's products out there, hellaciously expensive products nonetheless, that will take these services and run that same script from all over the world, and hit your service a ton and really give you an idea of what's going on. And this is actually a pretty good complement to that I'm going to build a production system and I'm going to hit it, or you could even do this during downtime. If I hit this, if I have a US-based population and I hit everyone at 2 o'clock in the morning Eastern from my worldwide network of servers, then I can get a good idea and maybe even break the service for relatively few people. And if I'm comfortable with that edge, then it works. So that's more or less how I think about load testing, what I've seen the products that do load testing do, and how, and there's a lot of stuff you can do on the back end. You can actually get a lot of mileage out of the approach of saying, let's script it, let's take it out there and scale both the front end and the back end and just see what happens. It's not wrong, but I can't help but feel that there's something a little better. So let's talk about it. Totally different topic. Half of what AppNeta does really talks to, I love talking to people who call themselves DevOps. I love talking to people who write code. The other half of the people we talk to, they're much more in the boat of, I don't have an application I run, I have 400 applications I run, 300 of which were purchased outside my department, and someone just gave me a support ticket to say that it stopped working. So that's hard. It's a little bit of a different task to deal with if it's not yours and you don't even know it happens and now you suddenly have to fix it. So one of the big tools in that toolkit is really just making sure that the underlying network works. And to do that, you can use Netflow. And Netflow, grab a Wikipedia quote, it allows you to look at traffic as it comes across routers and understand where that traffic's going, where it's come from, and what protocol it's using. So, again, Wikipedia. The standard way of doing this is you've got a bunch of different sites, sites or offices or network chunks, and they'll all actually emit. They'll inspect that traffic and emit Netflow data, and it's in terms of this 5-tuple, which is source IP and port. So where did I come from? Destination IP and port. Where am I going? And protocol. And that's the information you get. And this is pretty huge. IP gives you a lot of information. Port can tell you what type of things people are doing. If the reason that I can't get to Salesforce in my Iowa office is because someone's uploading, gazillions of gigs over FTP, then maybe that's a thing. Maybe if it's coming over SSL, that's a different story, and I can deal with it differently. So there's a lot of insight to be had in just understanding that sort of 5-tuple. And of course, once you have the information being emitted from those Netflow collectors or those Netflow exporters, then they're all shipped back to a collector somewhere that's got some interface, and you can look at charts and stuff like that. AppNeta actually does something like this. We don't use Netflow, capital N, capital F, per se, but we have the same sort of architecture where we actually look at what's going on and tell you a little bit more information about those particular packets. We'll actually look at the entire stream and tell you what application. So, this is our office, filtered to just the applications that look fun. So you can see a lot of YouTube in there. A couple of teams using Google Talk for video conferencing, and surprising amount of bandwidth going to Sears in this time. I don't know how anyone spends bandwidth going to Sears, but it is what it is. So this is a little bit of a more detailed approach, looking at every packet that comes by and trying to classify it. But it's basically the same idea. So anyone here ask anyone else the question, so what do you do? Where do you work? This is what we do. It's a big part of our business, and the thing that we're proud of is this idea that you can classify actual applications. So that's great, that's awesome. Turns out that's actually harder to do. Imagine that if you're looking at packets as they go by, pulling out just the source and IP from the packet headers takes a lot more just processing power on a CPU than looking at every single packet as it goes by and trying to find host headers in HTTP and trying to do fingerprinting on GoToMeeting or Google Plus Hangouts or whatever you have as they go by and trying to say, I know what that application is. But this isn't a talk about what AppNeta does. That we had the problem of trying to do this, knowing that it's more expensive, how do we know and quantify that? So there's a tool out there called TCP Replay. And what it'll actually do is it'll grab a packet capture, and when most people want to test their network for, say, security, they'll grab a packet capture. And they'll replay those packets back against the network, and they'll see what happens. And once they go fix the network, block the appropriate ports or whatever, then you can use TCP Replay to replay the same attack back and know that it's byte for byte the exact same, or byte for byte the same from a different IP, and know that it worked. So you're confident that it worked. And we said, well, that would be awesome if we could play back packets. But we don't want to play back packets a few at a time. We want to do a load test. We want to understand that on data center quality networks, 10 gig networks, how does this work? So TCP Replay is open source. We like open source. So one of our founders actually went and hacked on it for a few months. And he played a lot of the same tricks we play in our product, around really understanding how to put packets on the wire quickly. So skip the driver, write directly to memory, a bunch of good stuff like that. He wrote some blog posts on it, but I'll definitely share links if anyone's interested. And I've been in marketing too long to understand how that works. But we released this. He actually took over maintainership of this library, and there's a couple of major improvements that he made in this particular library. The biggest one was taking TCP Replay, and instead of letting it go from letting it sort of run at its whatever the CPU can do with talking through the kernel and a bunch of overhead, we said let's get it to 10 gig. So you can actually specify how much bandwidth you want it to take, and this is just off a laptop. And this is so you can see they're bolded. The actual achieved wire rate is 9.5 gig. So, pretty solid. We were able to control exactly how much traffic came out off of total commodity hardware. And this allowed us to not only saturate a network, and we're pretty sure that properly configured networks do in fact work. But the biggest challenge is do the tools that interact with that network at those crazy speeds work? And we can test our own tool with this. So that was awesome. We introduced a couple of other things as well. That you give, the way TCP Replay works is you give it a packet capture and it'll just play it and then hop back to the beginning and play it again. When you're looking at Netflow, remember that Netflow aggregates by source and destination IP, and what we do is strictly a superset of that. So that's one dimension. It makes it hard to work with. And what he did was add this option that'll actually rewrite the packet capture on the fly and give you different IPs for each one. Because we're not just testing the collectors or the exporters of Netflow, we're actually testing the collection service as well. If you got 10 gig at one site or 5 sites or 10 sites, that's a lot of data you're analyzing, a lot that you're pulling back, and those records actually become a storage burden. So we needed to test not only can we analyze all of these in real time and sort of look at all of the packets as they come through and then ship them back to our service as fast as possible, but I don't want the backend falling over because we just shuttle data back to it nonstop. So adding unique IP allows us to actually control the number of flow records that come out of this system. You can do this with a standard tool as well. And it's all based on this small flows.pcap, and there's a couple of example ones, so if you want to play around with it, they're on the site. You can just sort of say, what happens if I send 10 gigs of traffic right now to my coworker's computer? I wonder if it handles that. I haven't tried that yet, but I should. So that's sort of how that works. And this is our result. That, like I said, it's pretty easy to pull out flow records from a system. So if you start down here I apologize for the terrible quality. I pulled it off the blog where apparently we resized our images because that's good practice. But it means it's like 300 pixels wide. But the standard for most Netflow is you need to be able to do 50,000 records per minute. So okay, great, we're down here. All the other tools are down here. We passed our bar, but let's run the experiment. Let's run it out. And the blue line is what happens if you do standard Netflow. You ask like a Cisco router or whatever to export those records, and it's totally linear. You add more more flows, more data, and it just says, like, I got this. We're good up to about 90,000 record or flows per second. Industry benchmark is like 50,000. You have to be at 50,000 to, I don't know, be in the Gartner Magic Quadrant or whatever. 75,000, every vendor will tell you they do that, and then you go through a POC, and half of them get washed out because they can't actually do it with the right systems. So we were pretty proud of this result. You get up to 80,000, and then you start dropping stuff, we start falling over, but we've quantified it. We get it, we understand it. This was successful. And it was mostly a one-off thing because we're not planning on touching a lot of our FlowView collection anytime soon, but it did really help us understand what's going on with our product. Did we make the improvements we want to make, and can it handle real-world traffic? So, all right, why did I tell you about that? There's a couple of different things that I think this interaction between TCP replay and our product really got right, that I'd love to have conversations with any of you afterwards if you've got an idea of how to do this in web applications for either front-end, back-end, or the whole system. So the first one is that you pick the load. In many ways that the Apache Bench or running scripts or anything, we'll let you do that. I want X level of concurrency, so give me 10,000 users. I want 10 gigs of data, give me 10 gigs of data. Cool, that's awesome. This is from a blog post we wrote like 3 years ago using multi-mechanize, and I think Dan Kubrick might have even given a talk on it at this meetup. I can't remember. But if you test what you're looking, if you know what you're looking to test and have that lever directly that you can just push it up, I tend to think it's much more effective to drive it until it breaks and understand that breaking behavior instead of just sort of throwing a dart out there and saying, I got this, it behaves well at this level, because you're not really characterizing it at that point. This graph is actually looking at adding more load to Reddit. You can download the open source version of Reddit. And it turns out that in this particular system, if you only have like one WSGI server spun up behind it, one WSGI server can only process like 10 requests a second. It's not that great. And everything queues up behind it in Nginx. So controlling that load directly, really important. The second one, which I think is actually more important, is using real traffic. That the ability to take TCP replay and give it a chunk of data that you've actually used, you actually know has been on the network, and then, sure, you're replaying it, and you're rewriting some IP addresses. That real data is incredibly powerful because you don't have to guess. You don't have to think, well, I've got this e-commerce site and people like to buy things, I guess, and look at recommendations, so let's hit like those two things, and maybe the login page. Yeah, that seems good, right? And then your site goes down because someone searched for, put in a search phrase that was 10 words, and oops. Because you didn't look at what happened when a bunch of people search. It takes the guesswork out of it. So I think there's a lot of opportunity here. There's a lot of good tools out there where we're looking at what's happening on the front end in a programmatic way. Everything with Episodes.js, there's a bunch of vendors who do RUM, and I think there's a lot of work yet to be done there, especially with a lot of the new APIs that we're working on to get that 6 months out of date at this point. But there's a lot of good information that you can pull directly from the browser and understand how people are using your site. Aggregate that, use that as your load test. I think would be much more powerful than simply scripting out, or at least use that as the basis of your scripting. And then the third one is, I think it's crucial to understand what are the sticky points in your application. What are the points or the variables that when you change them, things go wrong. It's not just that adding more connections will always make things fall over. If I'm adding more connections to my homepage, and my homepage is varnished behind it, I'm not testing my application. What I need to test is I need to test, 50 users concurrently hitting the database instead of 10,000 users hitting a static HTML page. Understanding exactly what's going on around those points in your system where you're worried about them, you're thinking about them, I think is far more valuable than simply throwing a bunch of load at a system and hoping it doesn't fall over. So one recent example of this is we use Amazon and S3 to store a bunch of our data. So you send us data, we process it, it sort of goes through a RabbitMQ thing, and We pull data off, and the first thing that we do is we do raw storage up in S3. And we thought to test how much throughput we could handle. We got a good idea of what are the things we need to do in order to get better throughput at that and where our bottlenecks are. There's one or two parts of the system that are not single point of failures, but a little bit more constrained than something like pulling tasks off of RabbitMQ, which will happily handle 100 different workers all at once. So what happened when S3 decided that all of a sudden it wasn't going to respond in its normal 50 milliseconds and said it was going to take 2 seconds to respond? And that sort of knowledge around, it's not that we're adding more tasks to the system, which we understood pretty well. There's a totally different concern around what if the tasks just take longer? And we'd seen this one or two times, and I think this really drove it home that we've seen if people send us data that's bigger than what we expect. Most of the time we collect data that's, a given set of metrics is like 100K or something like that. Occasionally, in certain pathological cases, that goes up to 500 megs. So what happens when you have to process that much more data, 50,000 times more data? What happens when the systems you rely on move in a direction that you don't expect? And you've seen this happen in the past. So you're testing against the sort of things that aren't just higher scale, bigger and better, but more things that may change, not as a result of your company growing. Interestingly, with S3, we saw a little bit of internal structure to how S3 works. This is sort of a scatter plot of all the different latencies that we saw to S3 itself. And it looks like S3, if it's failing, has a 2-second internal timeout. And that's why we were seeing 2 seconds initially, is because it would fail the first one, and then it would wait 2 seconds and try the put again, and in some cases actually take 4 seconds before coming back. So neat stuff. Turns out that we could actually spin up more nodes and fix it. So we got a pass with this one, but again, it caught us by surprise. So knowing those three things, I think are a good direction to take this. And I'd love to talk with any of you about that or hear any questions. So thank you.
Points 2 and 3 seem a little at odds with one another to me if you're having trouble identifying what the sticky points are, maybe. So if you had to kind of pick going with the scaling of what you'd see as, normal use patterns or traffic, as opposed to things that could be not abnormal that would break your system. If you had to pick one, what do you think is more important?
Sure. I think real data is more important. Yeah. That's the biggest thing that it even becomes an organizational challenge to look at, to get people to understand that the way the system is used and the way the system is developed and thought it was going to be used is just totally different. And if you can even push that down, there's even a whole other world, which I won't get into, of sales and marketing, where the things the sales guys say about it is nothing to do with what it does. And I definitely don't encourage that behavior because it sells software. But the more you can do to really align people and have them understand that, I think that's more important than guessing and checking.
Yeah.
Any other questions?
Much of the time, real data is boring. How do you make sure you're capturing the interesting real data?
That's a good question. I like to think that when you're capturing real data, I guess I use real data as a proxy for you should try and identify what's going on and use that as a place to start. One tactic we've used pretty successfully on our processing pipeline is that we have a set of real data that's just like a snapshot. It's like, here's 10 minutes of stuff. And then there's curveballs. Something goes wrong once, and you take that one thing and you add it to the normal data set, and all of a sudden, a few months go by and the normal data set is half normal and half just total pathological cases. So maybe it's not totally normal anymore, and you have to renormalize around that. But when it comes to like actually running a load test, I think straight up normal data is probably more helpful, because it is boring, and that is what's going to happen in production. And if something is pathological and goes wrong, that should be way early in your testing cycles. It should be correctness testing, or it should just be operational insight that you have tools to identify on the fly. So load testing lives in this sort of strange, step 3 of 5 in your deploy. And I think boring's okay there.
What do you recommend for people that don't have real data yet?
Scripting, it's not a bad idea. It's not wrong, honestly.
So at the beginning of your presentation, you mentioned, a number of ways to replicate your production environment to varying degrees. What did you do when you're replaying this data? What are you running this against?
So we don't do this as much as I'd like to. When we're actually testing FlowView, so on the web app side, we don't do a whole lot of load testing. Our approach right now is in many ways do it live, because the place where these sorts of things become scary are on the back end, and while we try and aim for real time, we've got a bunch of systems where if things start to go wrong, data will just back up, and we've got some time to react. Testing Netflow and using TCP replay against FlowView, we actually have hardware set up, and part of the way that we deploy, if you want the necessary horsepower to run that sort of thing, it's in many ways easier to try and get that functionality packaged up and out to some branch office in Iowa that doesn't have a technical lead there as physical hardware. So we have physical agents that are just like a little Linux box and UPS. So we had those locally, and we had a commodity hardware, and we just literally ran that system. So in our case, production wasn't as big and scary in many ways, so we got a pass. All right. Cool.
How do you test, cache-based data? So you run, you have a website or you have an application, and then you are caching more data as much as you can. But what you run into scenarios is you might not run into application database side issues, but what you might run into scenarios where, i.e. Chrome or something, suddenly can't handle that cache, or while you are giving live data to that cached instance, like a JavaScript or something like that, it takes a very long time to process it. But then by the time you even realize that something could happen if the system is already in production, and then you start facing these issues, how can you test these kind of scenarios? Does AppNeta have anything like that, or do you know of any tools which can simulate behaviors like those?
So I unfortunately don't know of any tools. I'd love to stand up here and tell you AppNeta could do all this stuff, but I guess the way we have actually at AppNeta run into situations where when monitoring code in production, caching actually really hurts your visibility into the system. And I think a big part of that is there's a model in my head and in a lot of people's heads where you're looking at the system as a bunch of connected pieces that don't hit cache. And cache is an optimization on top of that. The most extreme examples are something like heavily service-oriented architectures where you've got like a front end and it pulls from 50 different services on the back end, and all of them either have, those services provide a cache, or the front end itself, has some wrapper that caches everything whenever it can. And like the model of the system that we tend to use is, here's your front end and it talks to these 50 services. But the normal case is, here's this front end, it talks to one service and 49 lines in the cache. So I think you need to sort of separate those two concerns, which is, are you testing for the normal case? Are you testing for Chrome correctly caching all the assets that come off CDNs or whatever's in your backend? In which case, we'll just go for that, it's fine. Or are you testing what might be a 0.5% or 1% behavior, where you've got people with older browsers or strange security policies or broken DNS entries or something like that, and do you handle that case specifically? So unfortunately, I think a lot of that means is sort of point 3, which is knowing what you're trying to test for and what will break under specific conditions. And until you have a good guess at what those things are and know that you're protecting against something that is reasonable to invest the time into protecting, then it can be hard to get that insight. I'd love for there to be a tool that did that, if anyone has that. please tell me.
Have you any tips on rewriting the data? So, like, I guess that sometimes you'll want to immunize the data a bit so you don't do something silly like send a user 10,000 emails, but then at the same time, if you change it too much, it's not really production data anymore, or it's not really real. You know, you any experience or?
I don't think there's a silver bullet.
No.
You have to do those things. The less you change and the more you abstract, the better it is. You know, there's the whole Heroku 12-factor app thing where they talk about, and one of the factors is attached resources, where you can swap out a real database send or email send versus dev null versus send me the email versus. So I think just thinking about that as your functionality is as written, and then you have configuration, which is totally separate from the code, and you can attach and detach resources, and that gives you a lot more confidence that it actually works.
That's true.
All right. Well, thanks again, everyone, and if you're interested, we're hiring.